Hi, you're welcome to Courses Academy. Please help me by sharing my videos if you find them interesting. On our screen today, we have a question which says, what is the effect of increasing the pressure on the equilibrium reaction above? Now, since these people are equally talking about equilibrium again, we have to talk about it. Now, before we dive into this, let's try to remember something. The factors that affect equilibrium position. The factors that affect what? Equilibrium position. Now, what are the factors that affect equilibrium position? The first factor I will talk about is concentration. Is what? Concentration. Now, the next one I would like to talk about, I will talk about this number 2, pressure. Then lastly, I'll talk about number 3, which is what? Temperature. I hope it makes sense. Now, these are the factors that are the factors. Catalyst does not affect equilibrium position. Does it make sense? So, the first one, concentration. Now, talking about concentration, how does it affect equilibrium position? Now, I've made a video under rates of chemical reaction. Concentration is a factor that affects rates of a reaction, right? Now, listen up. It's very simple. Assume or think of a scenario whereby you have many cars on a highway. Now, when you have many cars, you see that to some extent cars will start colliding. Now, this collision might bring about accidents. Now, this accident is the consequence of cars being what? Cars colliding with each other. Why the cars actually are the antecedent? What really happened? Okay, collision is the antecedent, then accident becomes the consequence. Do you understand? So when there is more cars, when there are many cars, you see that there is high tendency of accident occurring. So in equilibrium position, now when you increase, if you have a reaction A plus B, and if it is reversible, to give C and what? D. So when A is reacting with B, when you increase the concentration of any of these reactants, when you increase the concentration, it will increase the rate of formation of the product. Now, it will increase the forward reaction. Yes, you are going in line with what it wants. So it will increase the forward reaction. It will shift the equilibrium position to the right. Whatsoever that is increasing forward reaction shifts equilibrium position to the right. Now, it will favor the formation of this product. But if you decrease the concentration, of the reactants now, what happens? It will favor the backward reaction. These products now will start forming the what? Reactant. Whatever that favors backward reaction will favor the formation of the reactant, and it will shift the equilibrium position to the left. I hope it makes sense. So under concentration, you see that to some extent is simple. Now let's talk about pressure. Now this concentration, please take note, is actually for, let's say, solids and liquids. Do you understand? But for pressure, we are talking about what? Gases. Pressure affects what? Gases. Does it make sense? So if I have a reaction that pressure has to affect, we have rules for pressure to affect the equilibrium position of that particular reaction. Now, the first rule is that one of the reactants on one of the products must be gaseous. You must have at least one gaseous reactant and one gaseous what? Product. One of them must be what? Reactant. If you have gases at the reactant side and solids and liquid or liquid at the product side, pressure can never affect. So the first rule is what? The reactant and the product, one of them must be what? Gases for what? A reaction to occur. I hope it makes sense. For like this one now, if I have that A is a gas and C is a what? A gas, right? And let's say B and D are liquid. Yes, pressure to some extent will affect. Now the number two rule is that the number of mole of the gaseous reactants must not be equal to the number of mole of the gaseous product. Now, the number of mole of the gaseous reactants must not be equal to the number of mole of the gaseous what? product. Look at what I mean. If I have a reaction such that C reacted with D to give me A and F, and I have that C is a gas, D is a gas, and let's say A is liquid and F is what? A gas. Listen up. Now, and I have on C 2, I have on F, I have 3. Now watch out. Will pressure affect this? Listen up. For us to know whether pressure affects, we will check whether we have gases, any gas are the reactant and any gas are the product. That's the first thing we check. Now, do we have? Yes, we have gas, Okay, now it has obeyed the first rule. Now, let's check for the second rule. Now, for the second rule, number of mole of what? The gaseous reactants must not be equal to the number of mole of the gaseous product. Now, the number of mole of the gaseous reactant, this is 2, I have 1 here. 2 plus 1 is 3. Now, what's the number of mole of the gaseous product? It is 3. So, is 3 equals 3? Yes. Therefore, pressure can never what? Affect this reaction. They must not be equal. Their number of moles must not be equal. Let's take another example. If I have the Haber process, that's the reaction between nitrogen and hydrogen to give is a reversible reaction to give ammonia. Now, all of them, they are gases. Now, will pressure affect? Let's check. First of all, we check for the first rule. We must have reactant, the gaseous reactant, we must have gaseous product. Now, I have gas here. Correct. Now, number 2, number of mole of the gaseous reactant must not be equal to number of mole of the gaseous product, right? Very good. So, I have the number of mole of the gaseous reactants, 1 plus 3, I have 4. Now, the number of mole of the gaseous product, I have 2. Are they equal? So, since they are not equal, pressure will do what? Can affect. I hope it makes sense. Pressure can do what? Can affect. Do you understand? So this is the idea on what? Pressure. Does it make sense? So the next one we'll be talking about is what? Is temperature. Temperature. Now this temperature, for us to define how temperature affects the equilibrium position of reactions, we must consider exothermic and endothermic reactions. We must consider what? Exothermic and what? Endothermic reactions. We must consider these two. Now, what is an exothermic reaction? An exothermic reaction is a reaction that gives out heat to the environment, to the surrounding. Does it make sense? Now, why an endothermic reaction is that which absorbs heat from the surrounding. Now, if we define it very well under rates of chemical reaction, it is found that the heat change of exothermic reaction is negative, and that the heat change of endothermic reaction is what? Is positive. Does it make sense? Now, you might be asking me, how do we know this? Now, heat change, that's the enthalpy, is defined by the formula H delta H is equals heat of product minus heat of what? Reactant. In exothermic reaction, the reactant is like a graph. The reactant is like this. The exothermic reaction always looks like this. The reactant is above, then you have something like this. So you have the reactants here, the products here. Does it make sense? So this is like a graph. You might have something, the value here, y and x, the value here must be above x, right? So if you ever want to find the heat change of an exothermic reaction, you will see that the heat of the product is x. So when x minus the bigger value, the smaller value, which is x, when it subtracts the what? The bigger value, you see that the answer will be negative. So that's why they say that the delta H is what? Negative. Why the one that happens in endothermic reaction, it looks like this, an endothermic reaction. Now the product will be what? Will now be what? Above. The product will be above. So these are the reactants and these are the what? Product. So you see that if here is x and here becomes what? Y. And the reaction is of this. So if I have HP, which is the highest value, y minus x will give us positive value. That's why delta H is positive. I hope it makes sense. So what happens when you increase the temperature of a reaction that is exothermic in nature? of a reaction that gives out heat to the environment. Now, since exothermic reaction gives out heat to the environment, it makes no sense for you to what? Apply heat in that reaction. It has heat. Do you understand? It's just like Davido. Davido, he has money, right? Very good. Now, if I give him something like 1K, does it make sense? It actually does not make sense. Do you understand? Because he has it. So exothermic reaction does not need heat. Rather, it gives out. He's the odogu in the game. So do you understand? So if I have a reaction, let's say a reaction A plus B to give G and H, and they told me that the reaction is exothermic. Now, how will they tell you? They'll write that delta H is equals minus VE, or they'll give you a value minus something, let's say minus 7. Whenever I see minus in the delta H, it is exothermic. Does it make sense? So whenever, and they tell you if you increase the temperature. Now, increasing the temperature does not make sense, since the reaction will give you out here. So there's no need of you increasing temperature. Do you understand? So increasing temperature in an exothermic reaction, what will it do? It will favor the backward reaction instead of it favoring the formation of the product. It will favor the backward reaction. To favor the backward reaction, favor the formation of the reactant, and it will shift the equilibrium position to the left. But when you decrease its temperature, since it has heat, if you decrease the temperature in form of removing heat from it, it will favor and forward the reaction, favor the formation of the product. It will favor the formation of the product and equally shift the equilibrium position to the right. Now, what happens in an endothermic? Endothermic is one that needs heat, right? So if you increase its temperature, yes, it will favor the forward reaction, shift the equilibrium position to the right, and favor the formation of the products. Now that's what happens. The vice versa happens when you decrease the temperature. So with this, I'll end this section with endothermic and exothermic reaction. If you have any question, you can ask. So the question on our screen: what is the effect of increasing the pressure on the equilibrium reaction above? Now take a look at that. Can pressure, now check, CuO plus H2. Now H2 is the gaseous part, and H2O is the gaseous part at the other one. Now rule 1 attained, right? Now rule 2, let's check. Number of mole of gaseous reactant is equals to number of mole of gaseous product. Number of mole of hydrogen gas is 1, and that of water is 1. So they are equal. Therefore, the answer is there is no effect. Pressure cannot affect that reaction, from what I've said. So I hope you learned something. Help me by sharing this video.